Very good. Good afternoon, everyone. Thanks for coming. My name is Jeff Brown, and I work on the Grails development team at OCI. I'll talk just briefly about OCI in just a moment. First of all, I want to give a big thanks to the conference organizers. You guys have done just a fantastic job again of putting the conference together. Thank you very much for doing that. We really appreciate that, and thank you for having me here to speak. So, thank you very much. So, as I said, I work for OCI. OCI is now the home of Grails and has been for about a year. OCI is based in St. Louis, Missouri, which is where I live. We've got about 125 engineers. We've been in business for over 20 years and have been an open source company since the very beginning. So that takes us all the way back to the mid to late 90s, before it was cool to be an open source company. OCI has been an open source company since the very beginning. And as of April of last year, so just about a year ago, OCI has been the home of the Grails team, and things have gone just really fantastic in that time. So we got started, the Grails practice at OCI got started in May of last year, and it was just the two of us, just Graham and I, made up we were the whole team a year ago. And so in the first year that the practice has been at OCI, we've made a whole lot of progress. There are now 12 of us working full-time on the Grails team at OCI. That's going really fantastic. There are 9 of us in the US and 3 here in Europe. We're going to need more, so if you're interested in doing Grails work with the core team at OCI, please send us an email at grailsjobs@ociweb.com, and I'd be happy to hear from you. And also happy to speak with you here in person this week while I'm here, so let me know if you'd like to talk about opportunities that we've got. During the first year at OCI, not only have we grown the team substantially, during that first year we've released more than 20 Grails releases. So that was a conscious decision that we made to start making smaller, more frequent releases that allows us to shorten the feedback loop, right? So when we make improvements, fix bugs, and add new features, it's likely that it'll only be 2 or 3 weeks before we can ship those features now, as opposed to waiting a couple of months or maybe longer. So our release cycle's been shorter, smaller, more frequent releases. We've gotten just fantastic feedback from our users. Folks like that. So most of that work is going on in the 3.0 and 3.1 line. 2.5 and Grails 2 in general is pretty much in maintenance mode. The only work we're doing in Grails 2.5 now is for if critical bug fixes come up, then those could go into 2.5. And support customers. So we have a lot of support contracts out there, and there are a lot of enterprises that still are still developing and maintaining Grails 2.5 applications. So if you're a support customer and you need a feature or a bug fix in 2.5, we do that. But in general, we're not innovating in 2.5. 2.5 is kind of is in maintenance mode. Only critical bug fixes and features for customers. So all of our innovation and most of our effort is going on, that's going on around Grails right now, is happening in Grails 3. So Grails 3.1.4 is the latest Grails release right now. This is probably the biggest blunder in the history of Grails, is we released Grails 3.1.4 on March 16th. 2 days after March 14th, we could have released Grails 3.1.4 on 3/14, and we missed that opportunity. I can't believe we missed that opportunity, but that disappoints me greatly. We could have released Grails 3.1.4 on Pi Day. We didn't do that. So 3.1.4, as of today, is the latest release that we've shipped. 3.1.5 will be released soon, and almost certainly 3.1.6 sometime after that. We've started doing development on Grails 3.2, and we've plotted the roadmap. So I don't want to spend too much more time talking about all of this, but just to provide a little bit of a sense. So we've plotted the roadmap for the next couple of years. We've got big plans for the framework. The framework is actively moving forward. So that's all fantastic. I couldn't be more optimistic about the progress that we're making and where we're going to be able to go with the framework over the next couple of years. All right, so what I want to talk about for most of our time today is testing in Grails 3. And what I've done is I've just selected a handful of scenarios and topics to talk about, that with the idea that even folks who have done maybe considerable Grails development, hopefully there'll be one or two little things here that maybe you didn't know about, or maybe I can clarify. Maybe there'll be some detail here that you weren't aware of. But I'm just going to go through a number of scenarios and talk about testing those scenarios, and hopefully that'll be an interesting learning experience. If you've got any questions or comments about any of this as we're moving along, don't feel like you need to wait until the end for Q&A. Get my attention. I have a little bit of a hard time seeing most of you, but raise your hand, get my attention, and I'm happy to make this as interactive as you like. So if you've got questions, please speak up. So we'll start with testing domain classes. So my own preference for how I put together domain classes in a Grails application is I like an anemic domain model. So I don't have a lot of behavior in my domain classes. Typically my domain classes declare persistent properties and some persistent stuff, like I might have before insert and after delete. There might be that kind of logic in my domain classes, but I don't put a lot of business logic in my domain classes. Generally, I'll put that in services or elsewhere. So often there's not a whole lot of logic in my domain classes, is the bottom line there. But there are things that I may want to test related to domain classes. So one might have to do with validation, right? So there are a number, even in this simple test right here, there are a number of interesting things to talk about. So this is a Spock specification, right? So class person spec extends spock.lang.specification. Spock is the default testing framework for Grails 3 applications. Spock is just fantastic, super cool, really powerful, expressive stuff. If you're not familiar with Spock, I definitely encourage you to investigate that. It's much more expressive, much more powerful. There's no good reason to write JUnit tests anymore, in my estimation. Spock is just a much better framework. How many of you are using Spock? Everyone, okay. So I don't need to preach about the benefits of Spock to you folks. All right, so I want to step through. There are a couple of interesting things in this test that I want to talk about. One is this test is annotated with @test4person. And so most of your unit tests, or at least a lot of your unit tests in a Grails application, will be annotated with @test4 something. And in this case, it's @test4person. At compile time, we recognize that this class is annotated with @test4person, and we'll look at whatever that type is, the word person in this case, and what type of object is being passed to the test4 annotation there affects what happens to this class, to this test class at compile time. So test4person, or test4 any domain class, will cause different things to be compiled into this test than if it was test4 a controller or a test4 a service, for example. And when we look at some of the other artifact type tests, we'll see some interesting things show up in the test as a result of that test4. In this particular case, we're not taking advantage of any custom methods, or so a little bit more on test4 later. But I've annotated the test class with test4person. That tells the compiler that this is a test for a domain class, and it's a test for that particular domain class, the person class. When you run your unit tests, your domain classes are mapped to an in-memory, a very simple in-memory map-based database. So GORM, of course, is the really powerful ORM tool that's part of Grails and has been since the very beginning. In the very beginning, GORM was really a really slick and powerful layer on top of Hibernate. And for some time, one of the most highly voted feature requests was to support JPA. So pretty early on, we separated GORM from Hibernate, so you could pull Hibernate out and plug in other implementations, like plug in some arbitrary JPA implementation. And then over the years, that abstraction got even better. There's a more clean separation between GORM and the persistence layer. And that was driven largely by the interest in using GORM to talk to non-relational databases. So a lot of folks wanted to use GORM to talk to MongoDB or Cassandra, or some so-called NoSQL database. So Gorm was separated not only from Hibernate, but separated from the idea of a relational database. And now you can use Gorm to talk to lots of different kinds of data stores. The Gorm that's in place when you run your unit tests is not using a relational database, at least by default. It's not using a relational database, and it's not using something like Mongo. It's using a simple in-memory map-based Gorm implementation. Since I've annotated this class with that test for person, the person class is rigged up as it's mapped to that in-memory database. If in your, and so this particular test isn't doing this, but if the test were invoking the save method or any Gorm method, so for example, if I called newperson.save, if I had not annotated this class with that test for, that wouldn't work. If I invoke any Gorm method on an entity that has not been configured in Gorm for this unit test, then I'll get an error that says, hey, you've tried to use this domain class outside of Grails application. If you're running in a unit test, make sure you mock that instance or something like that. I forget the details of the message. But it's not the case that in your unit test you can interact with any domain class and all the Gorm methods will work. You have to express which domain classes you want configured in that Gorm. And that's one of the things that happens as a result of that test for. So if I did create an instance of the person class and call save in this test, it would work because of that test for. Often you've got tests that are going to interact with more than one domain class, right? But the test for expresses what domain class is this test a test for. But it could be the case that this is a test for the person class, but I'm also going to be interacting with the address class or some other domain classes. And the way to express that is, since I'm really testing the person class, I would use test for person, and then in addition to that, I would use the @mock annotation, and the @mock annotation accepts a list of classes, and I could list any number of domain classes there, whatever domain classes I needed to be rigged up in Gorm in order to carry out this test. So in this case, our test is very simple. I don't have to mock any other domain classes. So what I really want to test here is some validation logic or some validators that I've expressed in the person class. So if we look at the first or the only line in the expect block there is creating an instance of the person class, initializing the age to be whatever person age is, so we'll get back to that in a minute, and then I'm validating that person and expecting validate to return some value. So there are two variables in that expression there. One is person age and the other is should be valid. So we'll come back to that line in a minute. Let's jump down to the where block. And in the where block, I've got this, you think of it as a table. This is a table of data. And the first row in that table looks like column headers where I see person age and then a pipe and then should be valid. I can have as many columns in this table as I like. And the way this works is Spock is going to execute this test over and over again, once for each row in this table. And what will happen is each time the test is run, so each time that expect block is executed, person age and should be valid will have potentially different values. So the first time the test is run, person age will be -2 and should be valid will be false. The second time the test is run, person age will be -1 and should be valid as false, and so forth. You can see the rest of the data there. So what I've got is a data-driven test here that describes kind of the boundary conditions of what are valid ages. So I can kind of guess from looking at this table that the valid ages for a person are 0 through 120. And any number less than 0 should be considered invalid, and any number greater than 120 should be considered invalid. So this test is going to run 8 or 9 times, however many rows are in that table there. Note that I've got the test method annotated with @unroll, and that's another Spock feature. Inside of that @unroll, the string that I'm passing to the unroll annotation, notice there's pound person age and there's pound should be valid are represented in that string. And what will happen is when this test case gets executed, if I'm running the test like in my IDE, where you see the list of all the test methods that were executed, instead of seeing just one test called test age validation, what I'll see is 8 different tests, and the test names will be whatever's expressed in that unroll annotation with the tokens replaced. So there'll be a test method called validate on a person with age -2 should have returned false. That'll be the name of the test method, right? So Spock is providing some really slick capabilities there, and one of the benefits of that over rigging this up, say the way you might have done this with a typical Groovy test case or a JUnit test case, is instead of just looping through all these values until you find one that fails, if you did do that, once you got to one that failed, the rest of them would not get executed, right? So you fix that one, and then that might lead you to another failure. The way this is set up, all of these test methods will be run, and if any of them fail, then you'll see them in the test failure report, but one failure does not prevent the rest of the tests from being executed. And one other thing I want to point out here is notice that when I call .validate, I'm passing a list of strings as an argument. And in this case, that list only includes one string, and that's the age attribute. It could be the case that the person class has lots of persistent properties, and in order to put the person class in a valid state, I might have to initialize all of those other properties, and that could complicate this test. Where really all this test is focused on is testing the validator for the age property. So even if there are a bunch of other persistent properties in the person class, and maybe a person has an address, and an address has a locale, and maybe I've got this complicated graph of objects, I don't have to initialize all of that just to run this test, right? If all I really want to do is test the validator for the age property, this is how I would do that. Call validate and tell Grails only validate the age property, right? So that list that's being passed to the validate method is a white list of properties that'll be validated when I call validate and pass that list as an argument. So hopefully that makes sense. Questions about any of that? Good. All right. Let's talk about a couple of controller-related testing scenarios. So here I've got a controller that has two controller actions in it, the index action and an action called create widget. And the create widget action accepts a widget parameter. And in this case, the widget class happens to be declared in the same source file as the demo controller, as the controller class. So all of this source code is in demo controller.groovy. When you declare a command object, like the widget class here, in the same source file as a controller that uses it as a command object, the compiler will recognize that and will do some special things to that widget class. In particular, one of the things that happens is the widget class is made validatable automatically at compile time. Even though we haven't expressed that it's validatable, it will be validatable because Grails recognizes that you're using it as a command object, so all of that is rigged up at compile time. So because the create widget method accepts a widget as a parameter, often when folks want to unit test this, what they'll do in the unit test is they'll create an instance of the widget class and pass that as an argument to the create widget method from the unit test. And you can do that, and that'll work, but I think a better idea is to not do that and to let the test go through the same code path that gets executed when the real application is running. So the way this works when the real application is running is if you send a request to the create widget action in this controller, Grails will create an instance of the widget class for you and will subject that instance to data binding, right? So if there are request parameters called width, height, and name, the values of those request parameters will be bound to the widget instance that was just created. Then the widget will be validated. And after all of that happens, Grails will invoke the create widget method and pass the widget instance as an argument. So I would set up the test to do the same thing, right? So notice that this test is not creating an instance of the widget class. It's populating request parameters, params.width equals 4, params.height equals 3, and so forth, and then invoking the no argument version of create widget, right? So the second to the last line in the when block there is the interesting bit. So we're invoking a method called create widget that does not accept a parameter. And if we go back and look at our source code, we see we didn't author such a method, right? There is no argument version of the create widget method in our source code, but the compiler generates one, right? So the Grails compiler recognizes that create widget accepts a request parameter. So we're creating another version of create widget that accepts no parameters, and then adding code to that method that does all the stuff I described earlier, that creates a widget, does data binding, does dependency injection, does validation. All of that logic is inside of the no argument create widget method, which is the method that we're executing here. Right?
Yeah.
Yes?
If you're testing data binding, would you pass the parent parameters as strings?
Yeah, it's a good point. The question is, since I'm testing data binding, should or would I say params.width equals 4 as a string, as opposed to 4 as a number? And in general, that's a better idea, right? So I think a better practice here is for the number 4 and number 7 to be strings, because that more closely mimics what's actually going on in your application, right? You're not going to have request parameters that are integers. Your request parameters are going to be strings. In this case, I'm not too concerned about it, because I'm not concerned that something's going to go wrong converting the string 4 into the number 4. But just as a matter of best practice, I would say it's a better idea for those values to be strings. So it's a good catch. Does that make sense? Yep. Other questions about any of that? Yeah. So notice that the create widget method is returning something, right? So in my test, I'm grabbing a reference to whatever the create widget method returned, and it's going to be a map, right? It's going to be this map that you see there. In the map will be just one entry. The key in the map is called widget, and the value in the map is going to be the widget object that was passed as an argument there. So what this test is doing is asserting that that the model contains a widget and that the widget has the values that I expect it to have here. So in this particular case, and I've kept the example here just really simple to focus on the things that I wanted to talk about, there's not really any logic here that I'm trying to test, right? I'm not testing, there's no logic to test in this scenario. But I kept the scenario simple to, as I said, to talk about sort of some of the mechanics and things that are going on that relate to what I talked about. And that is that I think it makes the most sense to invoke the no argument method, let the framework create the command object for you and do all the stuff that it would normally do. And then you can carry on and test whatever logic is actually in the controller after all that has happened. So here I've got another unit test for that same controller. Since Grails 2. something, and I don't remember what version it changed in, but at some point we changed the default behavior for how empty request parameters are bound, or how empty request parameters are treated during data binding. So if a request parameter is an empty string, or let's say it's a blank string, it's a string that just has spaces in it, what the data binder will do by default is trim that string before data binding happens. So all of your string parameters are trimmed before data binding happens. And then separate from that, or in addition to that, if a request parameter is an empty string, that'll be converted to null before data binding happens. And for most use cases, that's the behavior you want. But you can turn that off, right? So a way to do that, the way to turn that off, is you can set a config property called grails.databinding.convert empty strings to null and turn that off. Maybe you don't want empty strings converted to null when the data binder is doing its thing. So in application.yaml, if you set that config value to false, like you see at the top there, that affects the data binder. That tells the data binder, don't convert empty strings to null. So here we've got a unit test that is testing that that's the case. This test would fail if that config setting at the top were not set. The very last assertion here that says widget.name equals empty string, that would fail because widget.name would be null. That's the default behavior. The config setting at the top turns that default behavior off. In Grails 2, you had the same sort of thing. The configuration setting wouldn't have been in YAML, it would have been in config.groovy. So you'd have something like grails.databinding.convert empty strings to null equals false. But in Grails 2, when you ran your unit tests, those config settings are not loaded, right? So you'd have to, there's another special thing you do in your unit test to rig up config settings that you want to affect your test. In Grails 3, that's not the case. So that setting in application.yaml will be respected when your unit tests are run. That's really what I'm demonstrating there. Questions about that? Good stuff. Testing tag libraries, right? So here we've got a couple of simple custom tags. So notice that these tags are in the demo namespace. We're going to see that show up in our unit tests. And I've got a couple of tags. I've got a tag called say hello that simply pipes some text to out, right? So this is a tag that's just generating some text. And that text is dynamically generated based on the value of some attributes that are, or an attribute that is specified or expected to be specified when the tag is invoked. So in particular, this tag is looking for an attribute called name. And it's going to create a string that is hi there, name, and that string will be piped out. And then I've got another tag called repeat, and the repeat tag grabs the value of the count attribute and then renders the body of the tag that many times. So here's this isn't really a unit testing thing, but here's a trick that a lot of folks aren't aware of, and that is the map. So one thing folks will do if they want to grab that attribute and turn it into a number is they might say adders.count.toInteger, right? Adders.count is going to grab the value of the count parameter, and then that toInteger will turn that into an int and return that. A problem with that is if you said adders.count.toInteger and adders.count doesn't exist, that's going to throw a null pointer exception, which is bad. The way this works is on adders there are methods that correspond to all of the 8 primitive types. So there's boolean, byte, char, short, int, long, float, double, whatever one I missed. So here we're calling adders.int and passing count as the first argument. That's going to grab the value of the count attribute, convert it to an int, and return that value. And if something goes wrong during that process, either because count doesn't exist or because count can't be converted to an int, maybe it's got letters in it or something, optionally you get to provide a second argument to the int method that is the default value. So what I'm saying here is that count is actually an optional attribute. If it's there, we're going to convert it to an integer and use it, and if it's not there, then the number 3 will be the default value for count. So adders.int is going to return an integer representation of what adders.count is, and if adders.count is not there, it'll return the number 3. Right? So I've got a test that just renders some text out, and then I've got a tag that renders the body over and over again based on the value of some attribute. So here's one way to test the first tag, right? The tag that just pipes some text to out. So here I've annotated the test with @test4 helper taglib. So the compiler recognizes that helper taglib is a taglib, and it will add a number of things to this test that are helpful when testing tag libraries. So for example, we add a method called applyTemplate to this test class. In this case, we're calling applyTemplate and passing a string, and that string represents code that might be in a GSP, right? Anything that's valid inside of a GSP could be represented in that string. So applyTemplate will evaluate that string as if it was GSP code and will return whatever the tag, in this case, whatever the tag pipes to out. So what I'm testing here is if I invoke demo:"say hello and specify name is Jeff, that the result of that is hi there Jeff is what the tag would have piped to the output stream. Right? And that applyTemplate method again is there because I annotated this test class with that test4 helper taglet. Here is a similar test that is testing the iterative tag, right? The tag that's going to render its body over and over again. So I'm invoking demo:"repeat with a count is equal to 4, and then the tag has a body, right? The body space, and if we scroll over to the right here, we'll see that we're asserting that what the tag did is generate the body, right? Because count was equal to 4. Make sense? Let's see. So here I'm testing what happens when I invoke the repeat tag and don't specify a value for the count. Remember, in the implementation, the default value is expressed to be the number 3, right? So I want to test that. I want to see what happens. Does this thing blow up if I don't specify the count? and that's what this test is covering, right? So I'm invoking repeat, not specifying the count, and the assertion there expects the tag to return the body, the body, the body, right? So the default value for count is 3. GSP tags can be invoked as methods in your application, right? So in a controller, if you want to invoke a tag and not have that tag write stuff to the response, but you want to get back whatever the tag would have written to the response, a way to do that is you can invoke any GSP tag as a method, and the way to do that is you invoke the tag name as a method on a dynamic variable whose name matches the namespace of the tag. So for example, in an application, if I wanted to invoke the say hello tag as a method, I would invoke demo.sayhello because demo is the namespace of our tag. In our unit test, the way to do that is to interact with a variable called taglib. So we saw that because this test is annotated with that test for, that the compiler added a method called applyTemplate to the test. Another thing that the compiler is adding to this test is a property called taglib. And this could be the entire test, right? So there's not code someplace here that's initializing taglib. That'll happen automatically. Taglib will be an instance of the class that this test is a test for. So taglib is going to be an instance of the helper taglib class. And I can interact with that the same way I could interact with tags in the running application. So I want to invoke the say hello tag and specify the name is Jeffrey. I expect that to return, hi there, Jeffrey. I can invoke the repeat tag and specify a count of 4. We expect yes, 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 yes. And if I invoke the repeat tag and don't specify a count, then I expect yes to be rendered 3 times. Right? So I've got a simple mechanism for testing tag libraries or custom tags that are defined in tag libraries there. Right. Let's talk about testing REST APIs a little bit. So here I've got, in a Grails 3 application, I can have a domain class that looks something like this, just a simple domain class with a few properties. And I could have a RESTful controller, a class that extends RESTful controller. In this case, I've specified the response formats that I want this RESTful controller to support are JSON and XML. And at least as of right now, there's no other logic in this controller. We'll evolve this a little bit and we'll have some other logic. But let's look at writing a unit test for testing a REST API. So in my URL mappings, I've mapped /albums to be the URI where I want to publish this REST API. So /albums is being mapped to this controller. Music controller is what's expressed right there. /albums is the root of our API. So a simple way to test a REST API from in your Grails application is to use a class called REST client, which is provided by this library, right? So I've added a test compile dependency on that library, and now I can write a test that takes advantage of that REST client class for making REST calls to my application. So this is an integration test, not a unit test. On that previous slide there, you'll see I typed Grails create integration test demo.musicfunctional. That creates the music functional spec under the source integration test folder, right? And the test will initially be annotated with @integration. It will not be annotated with @stepwise. I'm going to come back to that, but I had to add the stepwise annotation. I'll talk about what that is and why I want that in just a bit. I've got a property in the test that is an instance of the REST client class, and I can start using that thing. So here I've got a test in this integration test that tests how does the API behave if there are no albums in the database, right? So I want to send a GET request to albums, and this string right here is appended to the URL that I passed to the REST client constructor. So that's going to send a GET request to localhost :8080/albums. And what I expect to happen is I expect a 200 back. That's what HTTP status.ok is. I expect the content type to be JSON, and I expect the JSON body to be empty, right? I expect JSON, but I expect it to be empty because there are no albums in the database, right? So that's our first test. We'll come back to that after we need to introduce some other things, and then I'll come back to that. Here's another test that tests creating albums, right? So this time, instead of initiating a GET request, I'm initiating a POST request to /albums, and I want this request to have a body. And there are a couple different ways I can specify the JSON body. This is one, so I can say body : and then a map that describes what I want in the body of the request. And when I do that, I need to tell the REST client what content type I want the request's body to be formatted as. So I want the request content type to be content type.json. That's going to allow the REST client class to turn this map into JSON. That JSON will be put in the body of the request will happen, and then I can make assertions about the response. So I'm sending a request to create the album called Red by the band King Crimson, and the genre of this album is progressive rock. That's all being formatted as JSON, and when that line of code executes, the one line of code that's in the when block, that really is generating an HTTP request to the application. It's generating a real REST request, and the body's being parsed. It's very much like what's happening in your real application. So I generate that request and then make some assertions about how I expect the thing to behave. What I expect back is HTTP status.created should be the response status code. I expect the response content type to be application JSON. I'm expecting that I got JSON back, and then I'm effectively parsing the response and making assertions about what's in it, right? So I expect the response, the JSON response, to have an attribute called artist name that's equal to King Crimson. The title should be equal to Red, and the genre's name should be progressive rock, right? So I'm making claims about what's in the response there. Then I can generate another POST request to create a different album, and this is really more of the same. I'm just creating several albums here, and but I'm creating 3, I guess, and they're all doing the same thing. I populate the request with some JSON, initiate the post, get a response back, and then make some claims about what's in the response. Then later in the test, I might test retrieving albums, right? So here I'm sending a GET request to /albums, and I'm making an assertion that I get back a 200, that the content type is JSON, and this time I'm asserting that the content is not empty. Response.data.size is equal to 4. Contrast that with the very first test that we looked at, and right there, where I expect response.data.size to be equal to 0 when I send a GET request to /albums. That's because this test method is being executed when there are no albums in the database. So this is a good point to jump back up to the Stepwise annotation. So Stepwise, that's near the top of the slide here, is a Spock thing, and a couple of interesting things happen to this test because of the @Stepwise annotation. One is that tells Spock to execute the test methods in the order that they're defined in the source file. And as I'm iterating through these on the different slides, this is all one big source file, and the tests are defined in the order that we're looking at them. So the first test tests what happens if no albums exist. The second test is creating some albums. And then the third test is retrieving some albums. And these are all happening in order because the test is annotated with @Stepwise. That's one of the things that Stepwise causes to happen. Another thing that happens when you annotate the test with @Stepwise is as the test runner is moving through the test methods and executing them all, as soon as one of the tests fails, then Spock will sort of jump ship and abort and will stop executing tests. And the idea there is the only time that you would use Stepwise is if you want to make sure that these tests run in a certain order. And really the only time you want to make sure tests run in a certain order is when one test depends on another test having run before it. So if we get to a test that fails, there's no good, we probably don't need to carry on because the system's in a bad state. So there's no reason running tests that depend on a prior test having run before it if that prior test failed. So be aware of that. Stepwise causes the test to execute in order, and as soon as one fails, the rest of them will not execute. Right? And one more scenario I want to test here is what if the controller has some custom logic in it to affect the results somehow. So in this case, we've got logic in our controller that says if there is a genre request parameter that was sent as part of this request, then only return the albums that belong to that genre. Otherwise, we're going to return all the albums. So when I send a get request to /albums, like we did back here, right? What that's going to do is return all the albums that are in the database. If I send that same request, but I include a request parameter called genre, then what I want to happen is I only want to get back the albums that belong to that genre, right? So I've got some logic in the controller to make that happen here. And then to test that, I can do the same sort of thing I did to test the other scenario, but I need to specify a request parameter. So one way to do that is what you see near the top there where it says query : genre : progressive rock. That results in a request parameter called genre whose value is progressive rock being part of this request, right? So now when I send a get request to /albums, I expect, even though there are 4 albums in the database, I expect response.data.size to be equal to 2 because only 2 of the 4 albums are progressive rock albums, right? Does all that make sense? Good. Just a couple more things. Running tests. So if I want to run my unit tests, I've got a couple of different ways to run unit tests. I can run Grails test app unit. I can use Gradle to run the test, which is what I almost always do. Gradle w test. We'll use Gradle directly to run the unit tests. Another option I've got is maybe I only want to run the integration tests. So a way to do that is I can run Gradle w integration test, and all Gradle tasks can be abbreviated using the camel case pattern that you see here. So instead of typing out integration test, I could just type IT with an uppercase T. That'll only run the integration tests as opposed to this, which is going to run only the unit tests. And if I wanted to run all of them, I can run Gradle w check. That'll run unit tests and integration tests to run all my tests in my application, right? That makes sense? Very good. And we've got, I think, 2 minutes, 3 minutes. Any questions or any questions at all about Grails 3 and testing? Anything at all I can help you with? No questions? Yes?
For testing, it's possible to configure daemon. What does that daemon do?
Yeah, so the question is, what does the daemon do? So there are a couple of related things there. One, Gradle has a daemon that is kind of a warmed up JVM that'll be running in the background. So when you execute, trying to get to my test here. When you execute tests, or when we start up the running application, there's already a warmed up JVM that Gradle can communicate with, and you don't have to pay the JVM startup cost every time you run a test or every time you run your application. Notice that this test, the music functional spec, is annotated with @integration. That @integration is important. That tells the test runner that when this test runs, the whole JVM, the whole Grails not just the JVM, the whole Grails application environment has to be spun up. Your application's really running when this integration test runs. That happens because of that integration. One of the interesting things about that specifically relates to running your test from an IDE is in Grails 2, you couldn't really run your functional tests from the IDE without involving Grails directly, right? So if you ran your functional test from the IDE, you'd have to tell the IDE, go run the Grails functional tests, as opposed to just right-clicking on this test and saying run it as a unit test. In Grails 3, I can right-click in this test and say just run it as a unit test in the IDE. And because of that @integration annotation, what will happen when the IDE does that is Grails will be started up, and then this test will be executed against that running Grails application. And if I've got 400 integration tests that are all annotated with that integration, when I do that, the application is only started up once, and all of my tests are run against all my integration tests are run against that same instance of the Grails application. So we're not starting the whole environment up for every integration test. So if you run 50 or any number of integration tests that are annotated with that integration, they'll all share that same running Grails app instance, which is nice. Yep. Any other questions or comments? Very good. Thank you all very much. And if there's anything at all that I can do to help you out, please let me know.